All right, area of a triangle. You guys know how to find area of triangles, of right triangles, like no one's business. It's pretty basic. But as soon as I give you a triangle that is not a right triangle, I think you still can figure it out. But sometimes you guys are kind of like, what? What do I do? So let me go ahead and show you what I mean by that. So here it is, guys. Notes 27, area of a triangle. I'm going to label these vertices A, B, C. And usually, so angle A creates little a, so little a is this guy. Angle B creates little b, so little b is that guy. Usually the base is whatever segment is horizontal. And then angle C creates little c, so there's little c. And then the next thing we do is we know that area of a triangle is 1/2 base. The base is that little b there, times height. And how do you calculate the height? The height is always perpendicular. So here's your horizontal. You make a perpendicular line and you make it go towards vertex B here. So this is your height. That's a right angle, and I'm going to call this H. Does that make sense so far, guys? All right. So I think most of you guys, when you guys had this question on the SAT, I think most of you guys were able to successfully solve for H, which, you know, it didn't take that long. You just looked at angle A. So let's look at that. Let's look at H real quick with respect to angle A. So if I look at angle A and I'm looking at this green triangle right here, so I can see that I can write sine of angle A is equal to opposite H over hypotenuse C. So if I multiply both of those sides by C, I can see that I have H equals C sine A. Does that make sense to everyone? Okay, and then from there, I can go ahead and do a substitution into this H, and I can say area equals 1/2 B, and then substituting that C sine A, C sine A. And there it is, guys. I have a formula that I can find area of this specific triangle if given side B and side C and including angle A, where the two sides intersect. We call this an included angle. So let me put this in parentheses for good notes. An included angle if given side B and side C. Now be honest. Have you guys seen in some way, shape, or form this area, this formula for area of a triangle? Never? Oh man, okay. No big deal, guys. You're gonna see how to use it. It might have saved you a few seconds on the SAT, ACT. Those are not the only letters. If I want to use angle B, then I have to use the included sides A and C. So area equals 1/2 AC sine B. And I'll slow down. Well, that's crazy. Somehow Siri thought that I was talking to her because it said that it didn't get it or something. I don't know. Did I say something? I guess I said sine B. Did sine B sound like Siri? Okay. Anyways, so here we go. And if I want to use angle C, well, then the sides that I must have little a and I must have little b. So area equals 1/2 AB sine C. All three of those will give you the area of this triangle. And you can use all three of those to get the law of sine, but we're not going there. We're not going there, guys. All right. How do we use this? Like this, guys. It's very easy. So look at example 1. In triangle ABC, little a is 13, little b is 15, and angle C is 71 degrees. Find the area of the triangle. Look how easy it is, guys. NTS for not to scale. I'm going to label it A, B, C. Little a has to be this guy, which is 13 inches. Little b has to be this segment here, which is 15 inches, and angle C, that's 71 degrees. And I'm slowing down, guys. Notice that I have the 15 and the 13, and I have the included angle 71 degrees. You have everything you need, guys. Area is 1/2, 13 times 15, sine 71 degrees. You're literally going to type that into your calculator verbatim like that, guys. So here we go. I'm going to take out Desmos. So let me take Desmos out, guys. And share screen, Desmos. So here's Desmos, and I'm just going to go into a scientific calculator. I'm already in degree mode, perfect. 0.5 times, and I already forgot. What were my lengths, guys?
13, 15.
13 and 15, okay. 13, 15, and then I remember the angle. It was sine 71, right?
Yes.
So there it is. 92.188 square units, whatever those units were. 92.188. I can remember that. So I'm going to come back. 92.188, and my units are square inches. Don't call them inches squared, it's square inches. And there it is. You are done. I think that's worthy of a happy face. That's not the best happy faces I've done. Oh well, that's okay. And it's that simple, guys. So now when you get this on your SAT, ACT, you'll be able to get it like that, hopefully. All right, let's keep going. Example 2. And I probably should have put more white space on this one. It says find the area, and don't worry. Oh, by the way, you're gonna get really hyped when you get to the bottom one here. So make sure that give this one your A game here. Find the area of triangle JDH if little j is 5, little d is 7, and little h is 11. NTS for not to scale. And I'm just gonna draw some random triangle here. I'm gonna call that dude J. I'm gonna call this dude D. I'm gonna call this vertex H. So angle J creates little j, so this is 5 centimeters. Angle D creates little d, so this is 7 centimeters. And angle H creates little h, so this is 11 centimeters. All right, check this out, guys. From what we know, can we calculate the area of this triangle right off the bat? We cannot. We need an angle. Well, you actually can. You can actually calculate the area right off the bat, but that's for the next example. We need an angle. And here's where what we learned last week comes into play. So what law did we learn last week that we can use to find an angle, guys? The law of, start with a C.
Cosines.
Yeah, law of cosines. I don't know if you guys know sign language, but that's a C, that's an O. But anyways, so law of cosines. I'm going to find angle J. You can find any angle. It does not matter which one. And let's start taking advantage of the registers of the calculator, guys, because we're in 2021, so we want to use like technology. So let's find angle J. So if I'm going to find angle J, this dude is the one that's going to go on the outside. So I'm going to write 5 squared equals 7 squared plus 11 squared. So law of cosines is very similar to Pythagorean theorem, except you have an extra term minus 2 times 7 times 11 cosine of J. And I think I can do most of these without a calculator. 5 squared is 25, 7 squared is 49, 11 squared is 121, and I don't know what that one is. 2 times 7 is 14, and then 14 times 11, is it like 150 something? Or yeah, someone do that for me, guys. 2 times 7 times 11. $154. How come you guys didn't hook me up, guys? 25 equals, I'm just doing 49 plus 121. Let's see, 120 and 50, what's that, 70? 170 minus 154 cosine J. And then I'm just going to subtract the 170 from the 25, 7, 60, 50, Negative 145 equals a negative 154 cosine J. I'm going to divide both sides by that number, guys. So I'm going to write it right over here. I'm going to say cosine J equals 145 over 154. Now, sometimes I turn a little like dyslexic and I write numbers weird because especially when these numbers are all the same, it's the same digits, 145, 154. So angle J is equal to arc cosine of 145 over 154. Now, in case you don't know why I'm doing that, guys, I need an angle to figure out the area of this triangle. So there it is. I'm going to use Desmos to figure out that angle, and I'm going to call it J. I'm going to call it J. I always like that name, by the way, J. What's up, J? Okay, anyway. So here we go. I'm going to go arc cosine. Oh, wait, was it arc cosine? Yeah, it was arc cosine. Arc cosine, and was it 145 over 154?
Yes.
Okay. And I'm going to call this J. So let me go, let me get in front of it and go J equals. J equals. So there it is. J equals that number, 19.685 degrees. So I'm going to come back really quick, guys, really, really fast. Angle J is 19.685 degrees. All right, area. Area is 1/2 times 7 times 11 sine of J. I'm going to use the exact. I don't want to approximate. I'm going to use the exact that's in the calculator, guys, because something magical is going to happen. So check this out. Well, right now it's not exciting. It's the next one that's going to be super exciting. So let's see. 0.5 times 711. I think it was 711. Sine, oh, hold on. Let me go back. I think it's still calculated correctly because it's all a product. Sine of J. J. Close. Close. So there it is. 12.968. 12.9687. 9687. 12.96. I'm going to write a whole bunch of digits. Area equals 12.9687 and then square centimeters. Okay. Are you guys ready to be mind blown? No, I'm being serious, guys. This is going to be awesome. This is better than going to Six Flags. Okay, well, I don't know about that. But, all right, check this out. Look at this. Hero of Alexandria. I actually Googled him like last year sometime. So sometimes, depending on what Google site, some websites say Heron. This guy, look at the year that he created this formula, 100 BC. I'm not a history guru. I did read his biography and all that good stuff of what he's done. He's a really good mathematician and he's credited for several things. But he spent a good chunk of his life trying to figure out an area of a triangle. And he came up with this formula. And it's called Hero's formula. And depending on what website, some of them call them Herons. So look him up, Hero of Alexandria. And Hero's formula says area is equal to the square root of S minus A, S minus B, S minus C, a product of all that, where S is the semi-perimeter, which means half the perimeter, and A, B, and C are their sides. Now, he created this, look, that's 100 BC. You still got to count to 0, and then that's where we start in, right? So this is 2,100 years ago, because we're in the year 2021. So 2,121 years ago, he created this formula, or around there. And let's see if we get the exact area digit per digit. So first, let's calculate S. It says use Hero's formula to see if we get the same answer. So S is 1/2 7 plus 11 plus 5. So let's see, half of 11 plus 7, 18 plus 5, 18, 19, 21, 22, 18, 19, 21, 22, 23. That took longer. And then half of 23, 22, 11, 11.5. Okay, so if this is true, this should be the exact area as well. 11.5, 11.5 minus 11, 11.5 minus 7, 11.5 minus 5. And I can tell I'm excited, guys, because I went completely against what I usually do. When I write my formulas, I usually like to write the smallest number, like 11, the 5 first. But I guess technically this is the smallest number because 11.5 minus 11.5. Anyways, let me slow down because maybe some of you guys are like saying, Chavez, relax. What did I just do? I just used Hero's formula. That's all I did, guys. I just did this. And what am I looking for? I'm looking to see if I get the exact same formula, the same area, digit per digit. And remember, I want you guys to remember one thing. 2,100 years ago, they did not have calculators. They definitely did not have Desmos. 100%, I guarantee you they did not have Desmos. And so let's see how good this guy is without a calculator. Well, we have a calculator. So let's see how good with our calculator is his answer for how accurate it is for area of a triangle. So here's my answer that I want to get. Can you guys see that? 12.9687. And let's see how good he is. I'm going to go square root. And I'm going to type in 11.5 first. And I'm just going to type in the way that I wrote it in my notes, or in our notes right now. 11.5 minus 11. Close, open. 11.5 minus 7. Close, open. And 11.5 minus, here you go. Here's the moment of truth, 5. Oh my God, guys, look at that. It is digit per digit, the same thing. 12.96871235. Guys, he did this without a calculator 2,100 years ago. He devoted his life to get this answer for area of a triangle with 3 sides, any triangle, and he got it exact. No rounding, no nothing. He got it perfect. Don't you guys think this is amazing? I think it's amazing, guys. And look, check it out. 2,100 years ago, people are still talking about it. His name is Hero of Alexandria. So I don't know. You guys think you guys can contribute something that 2,000 years from now, people will be talking about you? Maybe make a formula or create something amazing with medicine or save millions of lives. Or that's amazing, guys. I really do think that's like super legit. We got the same answer. I thought that was cool, guys. I don't know what you guys think, but I thought that was really cool. Okay, let's continue, guys. Example 4. You guys don't look too entertained. I thought that was going to be more fun than Fiesta, Texas, guys. Example 4. The area of a triangle is 12. 2 of the side lengths are 4 and 9.6, and the included angle is acute. Oh, look, this one I took from Delta Math. Notice that it says included angle. It's talking about the angle between the 4 and the 9.6. So find the measure of the included angle to the nearest tenth of a degree. Okay, no big deal. Not to scale. So here we go. We draw a triangle for our visual learners. And we say this is 4, this is 9.6. And obviously it's not to scale, no big deal. This is the angle we're talking about. The area of that triangle is 12. And we're just going to use our formula. This is the included angle. Area is 1/2 base times height, or don't say base times height. Leg times leg, or 4 times 9.6. Sine of that specific angle. And that area is 12 here. So there it is. And now you're done. All you're doing is solving for sine theta. So 12 equals half of 4 is 2. And then double the 9.6, 18, 19. 0.6 is 1.2, 18, 19.2. Sine theta. I'm trying not to use a calculator, guys. And then all I'm going to do now is get sine theta by itself. So sine theta is equal to 12 divided by 19.2. And then to get theta, you just do arc sine. Arc sine of 12 divided by 19.2. And then I just go to Desmos like always. So let's go to Desmos. Desmos. And then what was it? 19.2. So arc sine of 12 divided by 19.2. 38.682 degrees. Oh wait, did I say nearest tenth? I'll figure out right now. To the nearest tenth of a degree. 38.682 degrees. The nearest tenth, so that means 38.7, the very first digit after the decimal. We feel okay, guys? All right, awesome. Example 5. The area of a parallelogram is 13, and the length of its sides are 9.5 and 1.7. Determine the nearest tenth of a degree, the measure of the acute angle of a parallelogram. All right, if you don't remember what a parallelogram are, wait, is that proper English? Parallelogram are? If you don't remember what a parallelogram is, I'm going to try to draw one. This is a parallelogram where the two opposite sides there are parallel, and these two opposite sides are parallel. And theta 1 plus theta 2 equals 180 degrees. Something else, you can also break this up into two triangles. And that's your height right there. You don't have to do that. Area of a parallelogram is base times height, where this is the base. So you can also do, if I call this A and I call that B, and I could just, well, I already labeled that theta 1. So area of the whole parallelogram is AB sine theta 1. And you can see that because the area of a triangle is 1/2 AB sine theta 1, and there's two of them. So 1/2 times 2 is just 1. Cool or not cool, guys? Yeah. Is anyone confused? Perfect. All right, guys. The parallelogram is 13, the area. So I'm going to write 13 equals. And they want me to find the acute angle, which is theta 1. So I'm going to go ahead and write 9.4 times 1.7. And I usually like to write the 1.7 first, so I don't know why I'm not being normal today. Sine theta 1. And I'm just going to multiply that 9.4 and that 1.7. So 9.4, I have a little calculator on my side here, times 1.7. I got 15.98. Chavez, why don't you use Desmos? I'm sorry, guys. Next time I'll use Desmos. Or I'll call you and you guys tell me. 15.98 sine theta 1. And I'm just going to divide by 15.98. Let me know if I make a mistake, because I make mistakes all the time, guys. 13 divided by 15.98. And then I'm going to do arc sine. So theta 1 is equal to arc sine of 13 divided by 15.98. So here we go. I'm going to take out Desmos. So 13, 15.98. Arc sine 13 divided by 15.98. 54.44 degrees, 441. I hope I did everything correct there. 54.441. 54.441 degrees. And nearest tenth, so 54.4. And there you go. We still doing okay, guys? Okay, awesome. Last one. I think this is the last one. Yeah. Sorry, guys. I just saw the chat. You can. For the last one, I would have, if you want to split it up into two triangles, I'm trying to reach a chat here. You could say that the area of the first triangle is 1/2 AB sine C, and then times 2 gives you the whole base if you wanted to. But you'll get the same answer anyways. So you could say like half of 13 over 2 equals 1/2. You'll get the same answer, so it doesn't matter. I hope I understood it correctly. Did I answer your question? Okay. All right. The area of a parallelogram is 21, and the length of its sides are 8.6 and 3.1. Determine to the nearest tenth of a degree the measure of the obtuse angle. Oh, I like this one. I like this one, guys. There's a reason why I like this one, guys. The reason why I like it is because the calculator will not give you the obtuse angle. The calculator will actually spit out an acute angle. Can someone tell me why? Can someone give me a counterexample?
Is it because the sides are different?
Well, I mean, the sides are always going to be different if it's a parallelogram. I think that's properties of a parallelogram. If not, it would be like, yeah. So let's try but any guess is a good guess. So why when I do the inverse sine of my formula, why will it not give me theta 2? Tell me something about the unit circle. Tell me something about this. Sine of some angle equals 1/2. Tell me something about that.
Emily says in the chat, is it because it's a different quadrant?
Kind of. I wouldn't call it quadrant because, you know, I'm looking at it and it's just theta 1 plus theta 2. But, okay, tell me what two angles for sine give me half. Sine of what angle is a half and sine of what other angle is a half? Uh-oh, do we know the unit circle, guys?
Is it 90 and
No.
270?
90, sine of 90 is 1.
Is it 30?
Yeah, 30 degrees. No matter what I do in the calculator, no matter how many times I type arc sine of half, the calculator is always going to spit 30 degrees. Always, 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 no matter what. All right, Chavez, where are you getting with this? Well, you and I know that that is not the only answer where sine is half. Sine is also half at 150 degrees. But how do I get the calculator to give me 150? Well, you're not. You're not going to get the calculator to give you 150. The calculator is always going to spit. If the ratio is positive, if I have a ratio that's positive, it's always going to give me an angle that is smaller than 90 degrees. It's always going to give you quadrant 1 of the unit circle. So how do you get the answer in quadrant 2, quote unquote? You go 180 minus arc sine of that half. That's how you get it. That's how you get the 150. That's why you have the 180 in front of the formula for arc sine for your second equation. So luckily for us, theta 1 plus theta 2 equals 180 as well, guys. So whenever I get my angle, I'm going to get angle for theta 1, and I'm just going to do 180 minus theta 1 to give me theta 2. Does that make sense? Okay, and don't worry, I'm going to go slow. So here we go, guys. All I'm doing is this. Area is equal to AB sine theta 1, and you can also say theta 2, and it actually will work. But I'm going to find theta 1 first. So here we go. My area is 21. And let's see, 3.1 times 8.6 sine theta 1. So go ahead and multiply the 3.1 times 8.6. I'm going to do it here on the side, guys. 3.1 times 8.6. And I got 26.66. So 21 equals 26.66 sine theta 1. Now I'm going to divide by 26.66. So now I get this. Sine theta 1 is equal to, well, I guess I don't want to do that. I want to do arc sine. Arc sine, so theta 1 is equal to arc sine of 21 divided by 26.66. So let's see what theta 1 is. So I go to my little calculator here. I'm going to label it a letter because I know that I'm going to need another, I'm going to have to subtract from 180. I'm going to call it A. A equals, and I'm going to go arc sine, and then it was 21 divided by 26.66, and there it is, 51.970 or 971, but that's not the answer I want. I want obtuse. That's what it said. Give me an obtuse answer. So 180 minus A, and there it is, guys, 128.029. So 128.029. So I'm going to come back, and I'm going to write theta 2 equals 128.029. Oh man, I can't even write 029 degrees. And it wants it to the nearest tenth. So 128.0. 128.0. And it still works. In case you're wondering, like, Chavez, do I get the 21 there? Check it out, guys. If I use, it doesn't matter which one. So let me prove it to you guys. So if I go, let's see, area of a parallelogram, A times B. So I already forgot my A and B. What was it? It was 3.1 and 8.6. So if I go 3.1 times 8.6, come on, buddy, 8.6. And I use sine of the A here. I have it saved as A. I get, look what you get, 21. Enter. If I use, I'm going to call this B. I'm going to go B equals that. B equals that. If I go 3.1 times 8.6, and I go sine of B, which is that 128.02 B, you still get what 21. See, it works, guys. It works. Cool or not cool?